This conference will now be recorded.
All right, hello everyone. This is Brian Gockel, Weather Service Office of OBS, welcoming you to this week's Satellite Book Club seminar series. Topic of our talk today is the GOES-18 ABI Barcode Artifact, and our speaker is Bill Line of NESDIS Star. Our facilitator today is Zach Hyris, meteorologist from WFO Boulder. A few reminders before we get underway. Session is being recorded. Q&A as usual at the end of the presentation. We encourage questions from all, and especially those in the field working with satellite data or wanting to work with satellite data. Very interested in hearing from the end users. We encourage you, as always, to sign in with your full names, and that'll help us field questions from the chat as well. It helps us keep track of all the attendees. If you're not receiving emails and expecting them, or maybe were and stopped receiving them, please check your email spam folders, as sometimes terrorist communications end up there. And so we'll get you back on the list if you're not on the list. Training team can help develop training materials, and that's a shout out for those interested in participating and presenting future Satellite Book Club seminar series. We welcome it, and Brian Mata can help with the development of your materials. Thank yous as always to the TOWER-S team, Kashad, OCLO, GOES-R, JPSS program, our facilitator and speaker. About to hand the mic over to Bill, but before we do, just a couple of words about Bill. He's a physical scientist with the NESDIS Star Regional and Mesoscale Meteorology branch in Fort Collins, Colorado. And in that capacity, he conducts research into the detection of various mesoscale phenomena utilizing NOAA satellite data. He's been a long-time enthusiastic of exploitation of satellite data across the weather enterprise, and so we're happy to have him here today. Bill, handing the mic over to you. Get it underway when you're ready.
All right, thank you so much, Brian, for the introduction, and thank you everyone for joining today on this unique, very important topic. Of course, we'll be talking about the GOES-18 Barcode Artifact, and I want to thank all the co-authors and the GOES-R Calibration Working Group and everyone that has been involved in identifying this artifact, characterizing it, and communicating it to our users, and so that they know what to expect when they're looking at imagery. All right, so this presentation is going to start with some of the important details up front, and then we'll get into a lot of examples so that our users can become a little more familiar with what the barcode artifact is and what it actually looks like. So for our key messages, as you're probably aware, GOES-18 has been serving as our operational GOES West satellite since early January. The ABI, or the imager instrument, is performing very well, meeting all of its requirements, and performs similarly with GOES-16, which is the GOES East. The one caveat is that the GOES-18 band 7, or your 3.9 micrometer band, has slightly higher noise than band 7 does on GOES-16 and GOES-17. Sometimes that noise actually organizes itself into north and south oriented bands of warm and cold stripes. This is what is known as the barcode artifact. This is typically more visible to the end user in uniformly cold scenes and animations, as well as time difference imagery. The barcode artifact does not have anything to do with the cooling system. Recall GOES-17, the previous GOES West satellite, had an issue with the cooling system that caused some horizontal artifacts. This has nothing to do with that. The cooling system on GOES-18 ABI is functioning as it should. We'll also talk about two events that have occurred that have actually led to a change in the appearance of the barcode artifact. And finally, it's really important to note that our investigations and interactions with the users have revealed that there's really no impact of this barcode artifact on feature detection. So from what we've observed, the barcode artifact does not have really any impact on the mission of the National Weather Service. but it still is important to communicate what it looks like so that users are not surprised. So today we'll be looking at various examples of how the barcode artifact might influence imagery that you are looking at, specifically within the Weather Service. So we're going to look at the single band channel 7 imagery, and we're also going to look at band difference imagery that involves channel 7. And this is really where the barcode artifact stands out, is when you take a difference with the 3.9 micrometer band, and you, the forecaster, are most used to using the fog difference, which is the long wave IR or 10.3 micrometer band minus channel 7 or minus 3.9 microns. Historically, this is what you'd used for your nighttime fog detection, and this fog difference is also a key component to the nighttime microphysics RGB. Therefore, that barcode artifact shows up there as well. So to you, the user, really the greatest impact is going to be in your nighttime low cloud detection and the fog difference and the nighttime microphysics RGB. We'll also look at geocolor imagery, which uses the fog difference at night, and the fog and low stratus product. I'm going to also look at comparisons between GOES-18 and GOES-17, and also a few time difference imagery examples, which help to also characterize the appearance of the barcode artifact. This is something that you're not viewing operationally, but something we can view to kind of monitor the character of the barcode artifact by taking a difference between the current channel 7 image with the previous channel 7 image. So I'll do examples. Up front, I wanted to show what it looks like now, and then we're going to kind of go through the history of what it has looked like. Again, as I mentioned, barcode artifact appears as vertically oriented bars that kind of jump around the scene currently. These are most apparent in cold scenes, so at night and in clouds, especially high clouds. So the products that you may see impacts are the single band 3.9 micrometer imagery, but really for the most part, it's really hard to see any impact on the single band imagery, as you can see in this example. You're really going to, as I mentioned, most often see impacts in differences involving band 7, such as the fog difference, which is in the middle of this animation. So if you look on the left part of the scene, in the upper level clouds, you could see occasional vertical bars, but also within the low clouds or the blues occasionally. You'll also see impacts of the barcode artifact within the nighttime microphysics RGB or RGBs that use the channel 7 difference at night, which is primarily nighttime microphysics. So that's why we're going to show a lot of examples of that as well. And you can see in this example, again, the occasional bar. You are unlikely to see impacts in non-channel 7 single band imagery, or you're not going to see impacts. This only impacts channel 7, at least that's visible to the user. You're not going to see impacts in products that don't use band 7, and you're unlikely to see impacts in level 2 products that use band 7, such as the fire products. So slowing that example down, because it is, especially over the internet, probably hard to see the bars. But so this is that same example, channel 7, single band imagery at the top, fog difference in the middle, and nighttime microphysics RGB again. This is at night, relatively cold scene. You could see with these arrows, I point to where the bars are most apparent in this image. So this is 1231 UTC. You could see over Wyoming two vertical bars. And again, these are just present for the single image. Once we go to the next image, they're gone from over Wyoming, but they appear over Washington and Oregon. Again, you could see it most apparent in the nighttime microphysics RGB, the fog difference. And in this example, you can see a slight sign of it in the single band imagery as well. And then we go to the following image, and you can see they jump again to the center of the scene, and again over Wyoming. So they're not, stationary. They're not impacting imagery over a given location. If you're, as a forecaster in a WFO, you're focusing on a much smaller area. So over a given night, you might only see a bar a few times, and it shouldn't really be impacting your ability to diagnose a cloud as being a low cloud and to monitor its movement. So now I want to kind of take a step back and look way back last summer at what the barcode artifact looked like. So this is nighttime microphysics RGB comparing GOES-17 on the left with GOES-18 on the right. This is again from last July, and you could see on the right in the animation, the BA we'd say is a lot more apparent to the user, and it's almost like a film of flickering vertical bars throughout the time that you don't see in the GOES-17 image on the left. And then if we look at that time difference imagery, this really helps to draw out the appearance of the barcode. Again, this is just single band channel 7 differencing the current image with the previous image. And you can see across the full scene, you see these kind of vertical bars, which again helps us to characterize where this is occurring and how often this is occurring. However, on September 22nd, the barcode artifact appearance changed, and we were delighted to see this change because it mostly went away. You could see on the left in nighttime microphysics RGB, again at night, the barcode is there on the 17th. However, if we jump to the 24th on the right over the same scene, however, after the 22nd, you see that the barcode artifact diminished significantly, and really after the 22nd, you'd only see impact maybe a couple times in the evening. So this is after the 22nd. So after the change, comparing GOES-17 on the left and GOES-18 on the right for the fog difference, and they look very, very similar. And again, during this period from September through Christmas, we didn't see much barcode artifact impact, only really a few times a night in GOES-18. And this shows that on the left, we saw kind of widespread barcode artifact influence, maybe only in 4 to 5 images over the course of a full night, and another 4 to 5 images with maybe only subtle barcode artifact. And then we got to Christmas time, Merry Christmas, and the barcode artifact appearance changed again. So we're looking at nighttime microphysics RGB over Alaska on the left before the change, before Christmas. Again, it wasn't too noticeable. There were a couple scenes a night where it flashed at you, but then it went away. After Christmas on the right, you see that the character changed considerably, I'd say. And how I kind of characterized it is that the artifact, or at least what was visible to the human eye, became more narrow, or these more narrow concentrated bars of change in the imagery that kind of jump around the image throughout the course of the evening. And that image on the right is pretty much where we've been since Christmas. Every image somewhere within the full disk and within the CONUS sector, you see a bar jumping around again, and at night in fog difference imagery or RGBs that use fog difference, such as nighttime microphysics RGB. So now we'll continue to look at some examples of the current state, the current character of barcode artifact in imagery that you folks are looking at from GOES West. So this is again another time difference imagery example, looking at the character now. You can see these bars are a lot more narrow and kind of randomly spaced throughout the scene. So here's a comparison, more recent, or sorry, not more recent. This is on January 4th, looking at GOES-17 while it was still operating alongside GOES-18. GOES-17 on the left, GOES-18 on the right. You could see in GOES-17, you don't get those vertical bars, while in GOES-18 on the right, you occasionally see a vertical bar in the nighttime microphysics. You could see them down here in the lower left portion of the scene occasionally, but also up in the low cloud area over the land, but very subtle. So moving ahead now to March, this was a couple weeks ago, looking at channel 7, PACUS imagery on the left, fog difference in the middle, nighttime microphysics RGB on the right. Hopefully these animations come through okay so that you could see the flashing of the bars across the scene. The point here being channel 7, single band imagery alone at night, you're not really seeing anything, but when you take the difference, again, you could see the bars kind of jumping around the scene. Similarly, in the fog difference and in the nighttime microphysics RGB. However, if you're not typically looking at a scene like that, as I mentioned before, especially in a WFO, you're focusing in on your area. So for example, over Seattle, nighttime microphysics RGB, same day, same night, March 22nd, you're focused in on your area, maybe monitoring these low clouds around the city of Seattle, around your airport, and you occasionally see a vertical bar, but it does not impact at all your ability to diagnose and track these low clouds around Seattle. So I'll go through this example very slow. So this is at 8:26 UTC. We go to the next time at 8:30, or skip ahead 2 times, 8:36 UTC, and you can see if I go back and forth, this very faint bar shows up in the imagery, but it doesn't really change the character of the low clouds that you're looking at. And you know, since it's there for only one image, it's not real. So you could kind of filter it out in a longer animation. But even still, again, it doesn't change the appearance of those low clouds. So now looking at another example over Alaska, looking at the 3 products, single band, channel 7 on the left, fog difference on the middle, and nighttime micro on the right. Over Alaska, lots of clouds, maybe slightly colder scene even in the clear skies over Alaska. So you do see those bars jumping around quite a bit within this 9-hour-long animation. If we take it slow though, look at, like, this is March 20th, look at a couple scans. I point out some of the bars present at 1350 UTC. You could see them in the high clouds, you could see them in the clear area, but again, they're not really influencing your ability to track these low clouds, especially if you're looking over the Anchorage area. At this time, you see 3 bars aligned north of Anchorage, but no impact on your ability to see and these low clouds moving around the area. Of course, the barcode artifact is also present in all sectors, full disk, the CONUS sector for GOES West, and the mesosector. So this was from a few days ago when there was a mesosector overnight or early morning over Colorado. You could see fog difference at the top, geocolor at night in the middle, and nighttime micro RGB on the bottom. And in all scenes, you see similar appearance of the barcode artifact, again, jumping around the scene as you monitor those low clouds filtering in across the northeast Colorado plains. So taking it slow again, we could see a very, very faint bar over around the I-25 corridor there within the low cloud area. The next minute, there's a bar, that bar disappeared. Another bar appears western Colorado, and then the next minute over the central Colorado mountains. This is a neat example showing the full PACUS sector on February 7th, where you see bars in the high clouds across the scene jumping around within the low clouds to the east and over the United States. But you don't really see so many over the southwest part of the scene around Hawaii, where you have a much warmer environment and less clouds. Kind of good example showing that they're most apparent or most visible in cold scenes and in clouds. And then getting to other multispectral or a level 2 product where you might see occasional influence of the barcode artifact. These are the fog and low stratus products. And if you look, concentrate your attention on kind of the middle of the scene in the top 2 examples, there are occasional bars that jump around within the fog and low stratus fields. There's one. So something to keep an eye out in these products as well. But again, only a single image, and then it'll move away. It's easy for you to comprehend that it's not real and it's the barcode artifact. So here I stop it and point out an image with the artifact. You can see in the cloud thickness product, and then the MVFR, IFR, and to a lesser extent LIFR. But just be aware that it will show up in this product. All right, now some other products, of course, leverage Ch07 and the fog difference, including the day snow fog RGB. This is a popular one, I know, for you folks for monitoring low clouds during the day and monitoring low clouds over snow. Of course, the fog difference in this product is the green component, but again, this is daytime, and we're even looking at clouds, but you're not seeing any influence of the barcode artifact in this product that you would be viewing during the day. The fire temperature RGB, of course, uses channel 7 as the red component, just the single band. If you're monitoring for fires during the day and night, in this RGB, you're not going to see any barcode artifact. Here's an example looking at fires over southeast Washington. And then one more example, the day cloud convection RGB uses the fog difference also as the green component, but again, daytime, and so you're not going to see any artifact in this product as well. All right, that's it for examples. There are a lot of resources out there. There's a great page that OSPO has available with a brief barcode artifact slide deck that kind of is a condensed version of this presentation. I've written up a few blog posts, including recently, on the barcode artifact. So if you want to look at some of these examples, they are available there. So that time difference imagery I showed and some other neat GOES ABI statistics are available on a SIMS website. If you want to get more into the details, that's there for you. And finally, most of you are probably aware of just general GOES imagery websites that are great for users. The Star Image Viewer, the Sierra Slider, and SSEC Geosphere are great for viewing GOES imagery. So to summarize, as I discussed, barcode artifact is present in GOES-18, which is our GOES West operational satellite channel 7. However, the artifact is most visible to the human eye in the fog difference and products that use that difference, most notably the nighttime microphysics RGB and geocolor. And that's most notable in cold scenes, including at night and at night in clouds. It's important to note that the barcode artifact appearance has changed over time, and we expect that it may continue to change in the future. However, it's our goal to keep the users aware of those changes when they might occur. And finally, as I've shown, and as we've heard from users, the barcode artifact really does not impact a human's ability to analyze the imagery and do their job. I'm happy to have a discussion now. I hope we can hear from some of our Western US folks to hear if they've noticed the barcode artifact and if it has had any impact on their operations, and also happy to take any questions. Thanks a lot for your attention today.
Thanks a lot, Bill, for a very interesting presentation. We'll again encourage everyone to remain on the call for a brief discussion here. And if you have any questions, really encourage you to ask them in the chat. But in the meantime, just want to give a quick heads up for next week. So in a week on Thursday, April 13th at 12 o'clock, Mark DeBruin, a former Hollings intern with the WFO Sioux Falls office, will be discussing the detection of hail swaths using GOES ABI data. And we also encourage attendees to contact the Tower S team, especially Lee Byerly and Kishad Bowman, for questions about the Satellite Book Club or for configuration of satellite products. So as we wait for a few more questions to filter in here, I've got a couple of my own that I'll be asking Bill. Again, encourage you to ask anything that you'd like in the chat. But my questions for Bill is one, do you have any resources being dedicated to further the investigation and recovery of imagery should that artifact become more impactful?
Yeah, Zach, good question. There are a few different groups looking into a variety of mitigation avenues. So that work is underway. However, any mitigation would only be implemented if the appearance of the barcode artifact worsened considerably from what it is now, and probably it would have to worsen compared to what it was originally. But yes, those efforts are underway.
Okay, great. And since you brought this up on this last slide here too, without knowing that root cause, do you have any concern that this will eventually impact humans' ability to analyze that imagery and start affecting some of the WFOs more directly?
Yeah, good question. Folks are, so on the root cause, we have found that barcode artifact is noise from electronics on the instrument. But given the history of the barcode artifact and what we know, as I mentioned, we expect that it might continue to change in appearance, but based on what we've observed so far from the artifact and what we know of the artifact, we're not concerned at this time that it would impact the National Weather Service mission. But as I mentioned, if it did grow considerably worse, which it would have to be considerably, because it's really not that bad right now, we would work towards those implementing mitigation measures. But yeah, at this time, we're not concerned that it would impact the mission.
Excellent. That's good news for people like me at the WFO. So we're starting to get a few questions from the audience. Again, if you have some that you haven't seen in the chat yet, feel free to ask on your own. But we'll kind of go in order here. So Matt Foster asks if the frequency or severity of the barcode artifact is affected by the viewing angle.
Yeah, thanks, Matt. And I welcome any of the co-authors to chime in as well. But from what I've seen, no, pretty consistent regardless of viewing angle. But if anyone else has seen otherwise, Matt or Tim, please chime in.
All right, and if they have any comments in chat, hopefully we see those filter in here soon. Next question came from Scott Lindstrom, but Aaron Jacobs was also wondering something similar. So Scott asks, I like a good mystery. Has anything been ruled out as to cause for the anomaly? I think he kind of already touched on this a little bit though.
Yeah, and yeah, I don't know the details, but as I mentioned, it's related to noise from electronics. Sorry, Scott.
All right, and looks like there's a question from Ryan Leach again, asking more about the reason why, but Bill, you've kind of touched on that again with the noise from the electronics. Frank, don't have a last name on this question, but a bit of a long shot. Can GOES East data be used to mitigate some of the reflection of the issue in the L2 products?
Possibly. Maybe that's one of the mitigation efforts. I'm not sure, and maybe someone
Hey, Bill.
to that. Yeah, go ahead, Liz.
Hey, this is Liz. Can I ask a follow-up question to whoever asked that question? What are you seeing in the level 2 products?
And Frank, if you could talk, go ahead. And maybe Frank means the RGB.
Oh, okay.
So Frank, if you could expand either verbally or in the chat, that'd be great.
Yeah, so just to clarify where I'm coming from, we don't know of any even remotely visible issues in the level 2 products, but I'm talking about the derived products generated on the ground system. I'm not talking about RGBs. So yeah, if you mean RGBs, I understand that question then.
And then Liz, thanks for your comment that there's no dependence or correlation with the viewing angle, to answer Matt's question. And Dan did point out that I did show an effect that, yeah, the fog and low stratus products are level 2 products. But I'm not aware of using GOES East to mitigate this. Go ahead, Zach.
Okay. So next question, two-part question here from Warren Blyer. One, are there ever cases where the artifact persists from one frame to the next? And two, are the artifacts always oriented in the same way? Or if not, what's the possible range?
Yeah, good question, Warren. Yeah, the artifacts are always vertically oriented, like what I've shown in all the examples, and what really shows up in these time difference examples. And I mean, and maybe randomly they might show up in a similar location 2 frames in a row, but I think that would be random for the most part. From what I've seen, they jump around. And I do want to note something I didn't mention is that I have more details on one of these slides. The the behavior of the barcode artifact. Now this is the old appearance, but it actually varies with swath. So within the GOES West CONUS sector, it scans 6 swaths from west to east or across the scene. So you might see sometimes a vertical bar, within a certain north to south region, and then all of a sudden cut off. And that's because, and you can see it good in this example, those are different scan swaths from the instrument. So you'll see the bars kind of jump around within those swaths and not be continuous throughout the full domain. But yeah, north to south orientation is what you should expect.
All right, this may be a better question for one of the engineers here, but Ryan Leach asks, what's different about the electronics on GOES-18 versus GOES-16 and 17 that may be causing that barcode artifact? And are there other differences we should notice between the satellites as a result?
Does anyone else want to take that question?
Yeah, Dan, Lindsay, do you want to take that, or do you want me to?
Yeah, I
Neither
can
of us
take
are
that.
engineers, to be clear, though. Okay.
Yeah, I'm definitely not an engineer. The answer is that there are no differences per se in the electronics. Now, one thing that hasn't been stated that might make this a little bit more understandable is the barcode exists in all 16 bands and all of our instrument, all of the ABIs that have been built. If you start playing with the raw data and you stretch the data on the very low radiance values, you can see this north-south pattern. So it's always there. The difference, though, is that in the 3.9 band of GOES-18, it's a higher level of noise, and so that noise is sort of overwhelming the signal that we want to get from either emitted or really emitted radiation from the Earth. But the vendor L3Harris is continuing to look at explaining sort of what aspect of the electronics is causing this, and they have ruled out a whole long list of things. These are all internal ABI engineering things that I don't really understand, but if they do come up with the true root cause, I think that they'll tell us, and then we'll be able to tell everybody else.
Excellent. Yep, thanks, Dan, for chiming in. Let's see, I don't think we've had any other questions come in. Still got a few minutes left, so a couple other questions that are left in our queue here. Got a question from Brian. Does there appear to be some vertical striping in the GOES-17 loop on the left side of slide 15 off the coast of California? Any thoughts to what that might be? And I think we kind of just had a brief explanation of that from Dan as well.
Yeah, I think that's probably what Dan was talking about. You see, especially in this scene, in the cold clouds, you might see some of that vertical striping, and you also see in the GOES-17 the horizontal striping having to do with the loop heat pipe. But yeah, good eye on that. But certainly not as apparent as you see with some of the bars on the right in GOES-18.
Excellent. And we just got one question from Scott Lindstrom in chat. Does the low radiance aspect that Dan mentioned mean that the northern hemisphere barcode happens differently than the southern hemisphere?
I haven't really looked at it in the southern hemisphere, so I can't tell you.
Yeah, this is Dan again. I may not completely understand your question. It's really any low radiance scene. And if you get lower radiances in winter or summer, regardless of where that is, then you'll see the barcode more there. That's the reason this happens, really is only noticeable at night, is because during the day we have a reflected component that raises the radiances everywhere. And the reason we see it in the difference products is because when you take the difference between two bands, you're sort of enhancing any existing noise that's there. So it makes complete sense that it's most noticeable with difference products at night, and also with very cold clouds, which is always noisy at 3.9, regardless of at night, regardless of what instrument we look at it.
Sure. And yeah, Scott did just follow up on the different times of the years. That was what his original question was referring to too. So looks like I've got one more question here. So again, this is from Brian. We see some ABI and GOES experts on the call. Anyone care to comment about what has been learned that might be applicable to minimizing / mitigating the risks of similar artifacts on the remaining ABI flight models that have not been launched? So for example, the ABI and GOES-U.
Bill, want me to take that one again?
Yeah, please, Dan.
Okay. Yeah, that's actually a really good question.
Yeah, Dan, do you want to do it? Or?
Oh, if you'd like to, Liz, go ahead.
No, that's okay.
Yeah, so we do have one more flight model left to launch, GOES-U, and I'll take this opportunity to advertise that we're about a year away from that launch. It's scheduled for April 2024. That will become GOES-19. It's currently sitting down at Lockheed Martin in Denver, completing its testing before it'll be shipped to Florida later this year to get ready for the launch, or maybe early next year. And they have been doing some specific ground testing on ABI to try to figure out if there's anything we can do now to minimize the barcode. And the short answer is there is. I don't know the details, or maybe I don't know if I'm supposed to share the details. Oh, go ahead.
Oh, okay. Well, I didn't realize we couldn't share it, but
yeah, I don't know what isn't in public. So, sorry, Liz, there's a delay, so we're talking over each other, sorry.
Thanks, Dan.
All right, and not seeing any more questions in here at this point. Again, thanks to Liz and Dan for hopping in and answering a couple of those questions as well. But assuming no more questions come in the next few seconds here, we'll turn this back over to Brian for some final comments.
Thanks, everyone.
All right, thanks so much, Zach, for your facilitation today, and thanks, Bill Line, for a really informative talk about the barcode. It's sort of unfolded in slow motion with bits and pieces coming out over the course of the year, and this is the nicest summary I've seen. Appreciate your walkthrough, the examples, as well as the references for where folks might find information online. As Zach mentioned earlier, please join us a week from today, usual time, Thursday the 13th, and Mark DeBruins will talk to us about the detection of hail from ABI. Until then, thanks again for your participation, and we'll see you then. Signing off.